Welcome to a reading from The Lucasian Legacy, the Lucasian Professorship of Mathematics at Cambridge University, 1663 to 1993, by Robert Bruen, as read by his son, Garth Bruen. Chapter 2, the 18th Century, Mathematics. Every country and every age has dominant terms which seem to obsess men's thoughts. Those of 18th century England were property, contract, trade, and profits. Sir Lewis Namier. Background. Under the reign of Queen Anne, 1702 to 1714, the Whigs lost much of their power while the Tories gained influence in Parliament. By the time Anne died in 1714, England had been irrevocably transformed from the monarchy of a century earlier. King George I assumed the crown and Parliament was opened in 1715. He was succeeded by his son George II in 1727, who in turn was succeeded by his son George III in 1760. George III was king until 1820. The crown was reasonably stable throughout the century except for 1788, when the king had a bout with mental illness. During the 1700s, Britain began to modernize in a number of areas. In the legal area, the first Copyright Act of 1709 was enacted and the Newspaper Stamp Act appeared in 1712. Banknotes were first issued in 1718. The first daily newspaper, the Daily Courant, appeared in London in 1702. The first evening newspaper appeared in 1706, but it was not until 1780 that the first Sunday newspapers appeared. The use of Latin in the legal system was prohibited in 1735. A long overdue progressive move was made when the laws against witchcraft were repealed in 1736. The last witch had been executed in 1712. In 1737, the Licensing Act started the control of public theatre in London, assigning the role of censor to Lord Chamberlain. In 1751, January 1st was declared New Year's Day, and in 1752, Britain switched to the Gregorian calendar. September 2nd jumped to September 14th in one day. In the political arena, England and Scotland joined to create Great Britain in 1707. Ireland was declared indispensable to England in 1719, setting in motion difficulties that continue 275 years later. A symbolic and practical building was erected at 10 Downing Street in Westminster in 1731 for the purpose of housing the Prime Minister. The direction of government was quite clear. The institution of government was being established to replace the monarchy. In the early years of the 1700s, Britain had stepped up its colonization of America along the mid-Atlantic coast and in New England. By the 1760s, trouble in these areas progressed to the point of revolution that ended in 1783, with Britain acknowledging the sovereignty of the United States. At the end of the century, in 1798, in response to the costs of war, Britain instituted an income tax of 10% on incomes over £200. In addition to war with America, Spain had declared war on Britain in 1779. Moreover, Britain was engaged in wars in India, and the French had declared war on Britain in 1744. It was a century of constant warfare for Britain and the rest of Europe. Near the century's close, the Industrial Revolution began in Britain, and slowly spread across the globe, causing widespread advances in production capabilities and economic disruption for workers. Looking at the universities, in many ways the Cambridge of 1700 was not much different from the Cambridge 50 years earlier. Although the personalities were different, activities remained the same. Religious men controlled the universities through the government, using laws, acts, and finances to achieve their ends. The doctrines of those in power at the moment were forced on academics, although more and more toleration was allowed as time passed. It was not until the 19th century that dissenters were allowed the same rights as those who were members of the Church of England. Toleration was seldom countenanced, but the universities did more than worry about religious allegiance. They carried on with teaching and other academic pursuits, such as mathematics as always, while the rest of the country moved forward. Mathematics in the 18th century did not develop in England as well as on the continent of Europe. Although the mathematicians were first-rate in terms of their ability, they did not have creative insight or motivation to improve. There were some bright spots, however. Mathematics saw the introduction of pi to represent the ratio of the circumference of a circle to its diameter, e to represent the natural logarithm, and I to represent the square root of -1. These were some of the small steps that led to big leaps later on. The period was one of establishing mathematical representations of important mathematical ideas. In chemistry, the 18th century brought a steady discovery of elements, including hydrogen, oxygen, nitrogen, chromium, titanium, and beryllium. The formation of water from the component parts hydrogen and oxygen was accomplished. Physics saw some movement forward as disagreement about fundamental laws occupied attention of those involved in trying to find solutions to existing problems, understanding the nature of the universe. Newton published Optics in 1704. He put forth his corpuscular theory of light. That is, light is comprised of particles. He allowed for wave-like behavior of light caused by these particles, causing vibrations in the ether. The existence of the ether was to be a question for the next 200 years. The ether was believed to be a medium that contained all objects in the universe. A number of theories of its makeup were discussed, including the idea that it was an elastic solid, or even a fluid with special properties. The discussion about the nature of light continued for the same 200 years. Was it wave-like or particle in nature? Evidence existed for both. Leonhard Euler, a Swiss mathematician responsible for many improvements in mathematics in the 18th century, figured out the mathematics for the refraction of light using waves. Each wavelength represented a particular color, which is still accepted as correct. This gave great impetus to acceptance of the wave theory. At the beginning of the 18th century, the first textbook on astronomy using gravity principles, Astronomae Physicae et Geometrae Elementa, was published by David Gregory. Newton was having an effect. Astronomy was becoming important as more than just an academic interest. It was used for the navigation of ships, giving it critical role in world exploration. In 1714, both England and France offered prizes to anyone who could devise an accurate method for determining longitude at sea. In today's world, it is hard to imagine that sailors were using methods just slightly better than guesswork to sail around the world. Europe's large-scale shipping industry required a more dependable method than simple guesswork. In 1752, Benjamin Franklin established the connection between electricity and lightning. Electricity would eventually play an important role in both our day-to-day lives and our understanding of the fundamental forces of nature. Towards the end of the century, more improvements in physics occurred when Henry Cavendish figured out gravitational constant G in Newton's equation. It was still unknown until 1798 and was an important addition to scientific understanding. The same year, Count Rumford, Benjamin Thompson, showed that the currently accepted theory of heat, the caloric theory, which postulated the heat in a fluid contained in objects, was incorrect. He proposed instead that heat was a form of motion happening as a consequence of friction. The progress of the 18th century was driven by the discoveries of Newton and by the indirect consequences of the idea that discoveries could be made. He demonstrated that a man could use mathematics and logic to understand principles which, when applied, gave people a control that had been beyond reach. He put the planets and the stars within everyone's grasp. The change at this point is not unlike the conquering of the sub-4-minute mile. Once it was accomplished, many runners were able to do it. No new techniques were required, just the breaking of the psychological barrier. The barrier that Newton broke was an important obstacle to progress in mathematics, science, and technology. The contributions in the 18th century came from all over Europe in many areas, but in England, the Lucasian professors struggled to keep up in mathematics. This century starts with William Whiston, a creative and vocal man, trying to explain much of the nature using Newton's discoveries. Thank you for listening to this segment of The Lucasian Legacy, the Lucasian Professorship of Mathematics at Cambridge University by Robert Bruen. To learn more or support this podcast, go to lucasianchair.org or our Instagram account, Lucasian Legacy.